Introduction. Bioplastics is a growing key factor in the food packaging sector among the consumers, transformers and manufacturers. The market of the bioplastics covers the sectors of the container and packing, products of catering, bags, consumer electronics, agriculture and horticulture, toy industry, textile, etc. This increase in the consumption is due to different factors: reduce the dependency on the fuels fossil, the interest of the society by ecological problems such as the global warming and climate change. This growing demand of more sustainable solutions is reflected in an increase of the capabilities of production of bioplastics. The forecasts predict that the capabilities of production will reach to more than 6 million of tons in 2017. However, the bioplastics sector has very specific market niches. The passage of these market niches to a more widespread use depends on several critical factors, such as improving the image of the companies, the cost or legislation, among others. Actual issues. Composting under controlled conditions of certain biopolymers is a key attribute in the world of plastics. While recycling is a costly, energetic process, such capacity allows containers to be disposed on the ground, since the biological degradation only produces water, carbon dioxide, and inorganic compounds without polluting waste. Biopolymers such as polyhydroxyalkanoates, PHAs, are a kind of polyester obtained by bacterial fermentation of a wide range of microorganisms. So several of them can obtain different copolymers that are more flexible materials. Within the family of PHAs copolymers that can be obtained, one of the most commercially available is the formed by the monomers 3HB and 3HV, that is, the copolyester copolymer PHB-PHV. This copolymer is one of the most versatile and is less rigid and less crystalline than homopolymer polyhydroxyl butyrate (PHB), as well as more easily processable using conventional methods of plastic transformation. A major disadvantage of this copolymer and PHAs in general is its low melt viscosity. For the extrusion and injection processes, the polymers must present high resistance and elasticity in the melt state. For example, without these properties, the bubble coalescence may occur during the foaming process. Other drawback to be solved is that the extraction process requires the use of organic solvents, chlorinated solvents and volatile organic compounds, with a high impact on the environment and on the production costs. Along with the required conditions of sterilization, the extraction process increases considerably the final price, around 35%. The increase in the demand for environment-friendly natural products based on renewable materials is the main impulse in the global market of PHA. The main applications of the PHA are within the industry of the container and the packaging, catering, biomedicine and agriculture. The packing absorbs around 80% of the PHA, followed by the catering sector. According to the forecast, the market of the PHA will grow from 10,000 tons in 2013 to 34,000 tons in 2018, with an annual growth of 27.7%. However, commercially available PHAs are 2 times more expensive than polylactic acid and 4 times more than commodity plastics used in packaging industry, so a more adequate solution. The Europha solution. The Europha project has the objective of developing of a plastic formulation based on PHA, which would reduce the costs of production by a combination of 2 main improvements. A. The use of mixed microbial cultures separately adapted to the process, and B. The use of sugar-rich waste from the food industry. By this way, companies can take advantage of the generated waste as raw material for the obtaining of a product of high added value, saving waste treatment-related costs. This aspect of the project represents a key point to cheapen the production of the PHA, one of the main obstacles for the implementation of this biopolymer in the plastic market. On the other hand, it will help to increase the European production volumes of this type of materials that are currently well below the levels of the US and China. Another important aspect is the improvement of the image and the marketing of the companies that use it. The developed formulation should be 100% biodegradable, which could be employed in the manufacture of films and foamed trays as substitutes for materials derived from petroleum that are currently used in the packaging industry. Also, the composition should have food contact approval. Methodology. The Euro PHA solution passed through 3 milestones in the PHA life cycle. 1. Production of PHA by mixed microbial cultures, which makes possible the use of cheap raw materials from the agri-food industry wastes. 2. Development of a clean extraction method for PHA, using physical techniques of extraction and using environmentally friendly purification. 3. Formulation of compostable bioplastics based on PHA for the production of films and foam trays for packaging industry. Because of their compostability, these containers can be disposed of along with food as organic waste. During Euro PHA, the PHA production was performed in a 3-stage production process involving mixed microbial cultures. The first step is the acidogenic fermentation, where the carbon source, in this case pulp fruit waste from a fruit juice company, is converted into a mixture of organic fermentation products, the precursors for PHA biosynthesis. The fermented stream produced is then fed to 2 subsequent reactors, the culture selection reactor, where microorganisms are selected based on their PHA storage ability through a regime of feast and famine, and the PHA production reactor, where the selected microorganisms accumulate PHA up to the culture's maximum capacity. The resulting PHA-enriched cells are then collected, and the PHA is extracted, purified, and finally processed. On the other hand, in order to achieve an optimal composition for processing by means of film blowing and foam injection, different additives are added to the formulations to improve its processability and confer different properties to the final material. The additives that have been used in the project are of natural origin and approved for food contact. Within the range of additives that use the thermoplastic industry, the following have been selected: other biopolymers and additives to improve the melt viscosity of PHA, nucleant agents to accelerate the crystallization rate during processing, as well as to help the foaming process, foaming agents, plasticizers, lubricants and processing aids, UV stabilizers to avoid degradation due to ultraviolet radiation, antimicrobial additives. Typical industrial processes such as film blowing and foam injection have been applied and developed within the Euro PHA project. Consortium. Euro PHA is thus a research for associations that will contribute to a wide dissemination and use to ensure that large communities of small and medium-sized enterprises benefit economically from the project results. Euro PHA Consortium comprises 4 associations of industrial companies, more than 85% of small and medium-sized enterprises within its members, from 4 different countries: FICOM from Spain, SPIF from Sweden, Plastipalis from France, and BPF from UK. It also includes 3 small and medium-sized companies from 2 more different countries: Hydro from Italy and Techno from Spain. Finally, it involves 3 RTD performers, independent from each other and from any other type of participant to carry out the R&D work: IBET from Portugal, EMPA from Switzerland, and INSP from Spain. Benefits. Food packaging with PHA bioplastic is the strategic action for the EC. The EC strategy, Innovating for Sustainable Growth, a Bioeconomy for Europe, aims at partially reducing the current EU dependence on non-renewable resources as high as 84.5% by the use of bio-based materials like bioplastics. Euro PHA has proved a new source from PHA to be used and also decreases PHA price, so we expect we can compete in price with petrochemicals. PHA matches consumer and manufacturer needs better than competitors. For the market of food and beverage packaging, PHA matches the trends better than petrochemical plastics and bio-based alternatives, polylactic acid and starch. PHA production from waste surplus is financially attractive for agro-food small and medium-sized enterprises. At the end of the project, the consortium succeeded in developing 2 suitable formulations for the transformation processes, with the required properties and capabilities for the packaging industry. The European project Europha is funded by the European Commission under the 7th Framework Programme, and 10 partners from different member states of the EU are involved. For more information, please contact Pedro Sanchez Sequier at psanchez@fecoam.es.